Yeah, so hello everyone. This will be a quick introduction to something called as the adapter pattern. So adapter pattern is one of the structural design patterns that was proposed by Gang of Four. So basically in this video we'll have a quick introduction to as to what the pattern is, and we'll look at a close to real life example of as to how this pattern will actually help, right? So refactoring.guru, I'll be taking reference from this website, and I have my own example that will be using it. I have my own example in Java that will be using to understand the adaptive pattern in depth. So basically adaptive is nothing but a pattern that helps us, or that allows objects with kind of incompatible interfaces to collaborate with each other. So a kind of a fun example would be, so you can see this, right? You have to move the car on the rail track, but you can't actually do it, so you need a car to rail adapter which will do it. So you can place the car on top of an object basically that suits the rails, and then you place your car on top of that, and then you can maybe move forward the car. So that's the kind of basic intent that this pattern provides, right? So another example for this may be, suppose you have from your stock data provider you get the JSON data in XML format, but you use a downstream library, or you use some other API that expects the data in a JSON. So you'll need to write an adapter that basically converts that XML to JSON. So that is where again the adapter pattern comes in, or like in words you can say an XML to JSON adapter can come in, right? So we'll just take a reference from this website for the good diagrams that it has, and then we'll move forward to the code, and there you'll get a very good understanding as to what the pattern exactly is. So if you look at it from a very higher level, so there are basically four things. One is the client, basically that you are that contains all the logic of the program that you are writing, and it has some interface in which it expects data or other classes to collaborate. Apart from that, you will have an adapter basically, so you'll be adapting to some particular interface that some other service is providing. And like fourth, you'll have that adaptee, which is nothing but maybe the object of that service, or anything to which the adapter will hold basically. So here it would be that service. So if you see this in a nutshell, the client is a class that contains the existing business logic of the program, and client interface will be the protocol to which all the other classes must follow to be able to collaborate with the client code. Now adapter we'll talk in depth about. So it is the class that will allow you to work with the service class as well, because the service class might be coming from a third party library, and that might not fit with your interface, right? So basically there are two types of adapter: an object adapter and a class adapter. So the most famously used is the object adapter, because it's kind of implementable in all programming languages. Class adapter is something that's not implementable in Java, because Java does not support multiple inheritance. It is possible in languages like C++. So this is for some another video. In this we'll be looking mostly into the object adapter. Now let's keep all the theory aside and directly jump into as to what the pattern offers you. So consider you are building your own stock trading application like Zerodha. Your company would be the next unicorn, and you want to support, so as of today you are supporting Bombay Stock Exchange and National Stock Exchange, right? So you create an interface for stock exchange and define methods for, say, executing the trade and getting the stock price. So users on your app might be interested in getting the stock price for various stock exchanges, and similarly like executing trades on those stock exchanges. So if you look at Bombay Stock Exchange ka implementation, like you can have any kind of implementation here, maybe calling some downstream API, calling BSC APIs to figure out the data, etc. So that is on you. So yeah, once the trade happens, is trade successful or not, we can return back to the client. But this logic here is not important as of now. Our main goal is to understand the pattern in depth. Similarly, stock price can have its own implementation. As of now, we have returned a static price, right? So yeah, actually this is the price today. Infosys closed on. So yeah, like that is one thing. Yeah, similarly, you can have an implementation on National Stock Exchange. Now, let's say you raised a lot of funding and investors really believe in your product, and through your product now, you want to open the gates to New York Stock Exchange as well. But implementing with the New York Stock Exchange API, kind of registering with them, and has a lot of things in place. You don't really want to do that. So you found this awesome company which just deals with the New York Stock Exchange and has all the necessary things there, like execute trade functionalities there. You can get the stock price, etc. So this is a small startup. You have a lot of money and you acquired the startup. Now you want to integrate their code base into your code base. Now if you look clearly, the functions here are different. Execute trade on NYSE, get NYSE stock price, and it expects it like this, not in the models that you have defined internally. So again, coming back to this implementation, let's take a reference from this image so things are crystal clear to you. So client is nothing but your stock trading application that you have, right? This interface is nothing but the stock exchange interface that you made that has like methods like execute trade and get stock price. Then service is nothing but the one coming from the library from the company you acquired, that is the New York Stock Exchange. Now, to be able to talk to this and have your system, have your system talk to this while implementing this interface, you need to implement an adapter. Now, the important word here is again adapter. So what this is basically doing is this adapts your particular implementation to the one provided by the library. So if you see here, so this is nothing but the adaptee, right? So this is nothing but the adaptee. So here you will have the usual methods, but inside these you will be calling the methods in the format specified by the adaptee. So when you execute trade, you implement according to this, but internally you use the object of the service that basically the library provided, and then you extract the values and send it out to the function that it expects. So what an adaptive class basically did is it made sure that you can talk to the interface or the object that is coming from the library while making sure that you are implementing the interface that is there in your application, the stock exchange interface. So if you see, the Bombay Stock Exchange and the National Stock Exchange that you implemented has the stock exchange thing in place, and the New York Stock Exchange, because you were using a third-party library, you created an adapter, called the methods using the adaptee object, and it also implemented the stock exchange interface at the end. Now let's just quickly look at the implementation as to how things will look like. So if you see, the implementation is pretty straightforward. I do not call a method like New York Stock Exchange as to what was provided here, execute trades on NYSE. I call a method that I have specified in my API, in my interface itself, execute trade and execute trade. So one important thing that you see here is we are following the single responsibility principle that's there in place. So that is very obvious. Another thing that's there is the open close principle. So the class is always open for extension and closed for modification. So any kind of extension that we want to do in this type of code base, we are open to do it, but closed for modification. We didn't change our interface. Our interface is as is. To adhere to the New York Stock Exchange, the object that's provided by the library, we created an adapter, and our adapter helped us, in maintaining that open closed principle again. So yeah, again, like another method that I'm calling is get stock price. Again, a New York Stock Exchange doesn't provide the get stock price method. It provides a get NYSE stock price, and this is being called from the get stock price that is being implemented by the New York Stock Exchange adapter. So Okay, now let's take a pause and understand as to what exactly happened. Though it was quite clear to us. Basically, all we did is, because this particular library was not adhering to the interface that we have defined in our application, or the client has defined in the application, we created an adapter that had nothing but an adaptee, which is nothing but the New York Stock Exchange, and we were calling the methods provided by that. So that is it. So I hope that you got a brief idea as to what adaptive pattern is, and how it really helps us. So in a nutshell, one good use case wherever you say you're designing something and you want to see whether you should use the adaptive pattern or not. If you're implementing with some legacy systems and they don't, obviously they won't implement the interfaces that you have defined, and you want your system to be extensible, you can create adaptives between the legacy systems and the systems that you have in place. Right. So again, this, as I told, it's a wonderful reference on refactoring.guru. I'll link it in the video description. Please go through it. But let's quickly see the applicability points that they have mentioned. We should use the adapter class when we want to use some existing class, but its interface isn't compatible with the rest of our code. As in our use case, this functionality was there, but this was not compatible with the rest of our code that's here. It's not following the stock exchange interface. So that is where it helps. Second is we use the pattern when we want to use several existing subclasses. Yeah, so again, this is one of the applicability, but one of the downsides is that there is a lot of duplicate code that happens, and like duplicacy is usually not considered good. And I'll be covering more about this when I make a video on the decorator pattern. So let's park this for now. Again, coming to the pros and cons that we have. Single responsibility principle we already discussed. Open close principle, we can always introduce new kind of adapters without having to modify the existing code that's present. Now, one thing, again, this is based on perspective. So if you are always pretty sure that you won't be having such cases, then you will obviously need an adapter whenever any requirements come. So yeah, but sometimes it increases the overall complexity of the code. So yeah, that is one thing that you can keep in mind. And apart from that, yeah, so this was about the pros and cons. We will also be discussing the relationship with other patterns, but I'll make a video on this at the end when I discuss all the patterns under the structural design patterns.